Hello guys, welcome back to another video. In this video we will consider an integral from 1 to infinity ln of x divided by x squared minus x dx. So how will we approach this problem? First we want to get rid of the ln, so we will introduce a substitution. Which substitution? X equals e to the y. From here we get that when we ln both sides, we get that y equals ln of x. And now when we put it back into our integral, from here we get that dx is just e to the y dy. When we put it back into our integral, if we plug in 1, we get 0. For infinity, we get infinity, of course. When x is e to the y, ln of e to the y is just y. And here we will have e to the 2y minus e to the y times e to the y dy. Alright, as you can see, the e to the y will cancel each other out. I mean one of them, and we are left out with this expression. And now what can we do? We can simply expand this bottom part into an infinite series because it will diverge. So what will we do? We will use a clever trick, and we will rewrite the bottom part as e to the y in the front, 1 minus e to the negative y dy. Now we have an integral from 0 to infinity, of course, e to the negative y over 1 minus e to the negative y. Now when we use the expansion 1 over 1 minus x, which equals a sum running from n equals 0 to infinity, x to the n, we will have e to the minus y, and y goes from 0 to infinity, so it will converge now when we expand it. So what do we get? We get an integral from 0 to infinity, a sum going from n equals 0 to infinity, e to the minus y to the power n, e to the minus y dy, which equals, we will take the sum out in the front, a sum running from n equals 0 to infinity, an integral from 0 to infinity, e to the minus y 1 plus n y dy. So what do we do now? We just need to solve this integral, of course. We will have a sum going from n equals 0 to infinity, an integral going from 0 to infinity, and now we will introduce a substitution. Y times 1 plus n equals some k. So we will have, I'm using this substitution, so I make it look like a gamma function. So when I differentiate both sides, I get dy equals dk over 1 plus n. And from here we can see that y equals k over 1 plus n. When we plug it all back in, we will have e to the negative k. Y becomes k over 1 plus n. And what is dy? It's just dk over 1. Sorry guys, let me write it a bit better. 1 plus n times dk over 1 plus n. And what does this equal to? We will have a sum going from 0 to infinity. We take both 1 over 1 plus n in the front, so we have 1 over 1 plus n, and this is squared, times an integral going from 0 to infinity, e to the negative k, just k here, dk. And now you can solve it using partial integration, but I will see that this is a gamma function. Gamma function is defined as follows: an integral from 0 to infinity, x to the s minus 1 e to the negative x dx. And I will see that this is just s minus 1, and here is the power 1, so s is 2 here, and we know that gamma of s is s minus 1 factorial. So in our case, s is just 2, so we'll have 2 factorial here, but that is just not 2 factorial, but this is just 1. This integral, it will be gamma of 2, which is just 2 minus 1 factorial, which is just 1. So here we have a sum going from n equals 0 to infinity, 1 over n plus 1, and then squared. And if we move the index to start from 1 to infinity, we will have 1 over n squared, and we all know that this equals pi squared over 6. This is a Basel problem. Alright guys, thanks for watching. Like, share, and subscribe if you want to see more of this, and see you in the next video. Bye guys.